Let's go back to the unit circle. So in example 3, it says solve the equation cosine of 2x equals negative root 3 over 2. You'll notice our trig equations are starting to get a little bit more complex. That's kind of the theme through 4.3 and 4.4, is we're just solving more and more complex trig equations. But notice that once again, hey, look at this. Negative root 3 over 2, that sounds familiar. This is a unit circle problem. So let's start by doing arc cosine on both sides so we can work on getting x by itself. So right now I have 2x equals arc cosine of negative root 3 over 2. So let's go to our unit circle and find the triangles that have this cosine value. So first off, I want a negative cosine value, so that's going to be quadrants 2 and 3. And this is root 3 over 2, so I want the x side of the triangle to be the longer side. So that's going to put me here and here. Both of those triangles have an x side or a cosine side of negative root 3 over 2. So what radians are these? Well, I know this one's going to be 5 pi 6, and this one is 7 pi 6. Now, notice one big difference in the wording of this problem versus the ones we did in the last two videos. It says, give the exact solutions which lie between 0 and 2 pi. So I want all the solutions that go between 0 and 2 pi. So we're going to start this by just listing all our solutions. So I have my 2x. That is still there. And my first all solution would be 5 pi 6 plus 2 pi k. That's my first all solution. My second all solution, so it also gets a 2x equals, would be 7 pi 6 plus 2 pi k. So those are both the equations for my all solutions. So if this problem said give all the solutions, this is what I would be working with. However, notice x is not by itself yet. So let's divide everything by 2. Or we can multiply by 1/2. That is the exact same thing as dividing by 2. So those 2's go away. I get x equals, multiply this together, should give me 5 pi 12ths. Plus, those 2's cancel, pi k. And this one gives me 7 pi 12ths plus pi k. So if the problem said find all the solutions, these would be my final answers. I'm done. However, the problem says only the ones between 0 and 2 pi. So what I'm going to do is take my solutions, my first solutions, 5 pi 12ths and 7 pi 12ths, and I'm going to start adding pi k over and over and over until it gets bigger than 2 pi. Now, I know some of us struggle with fractions a little bit, so here's what I'm going to do to make this a little easier. Notice that my denominator for these fractions are both 12ths. So instead of writing this as 2 pi, I'm going to write it as 24 pi 12ths. Notice that 24 12ths is still 2, so it's still the same thing, but I changed the denominator to match the denominator I've got here. So I'm going to add pi to these answers over and over and over again until my answers get bigger than 24 pi 12ths. That's when I know when to stop. Now, I can also do the same thing with pi. Change the denominator so it matches. So I'm going to change this to 12 pi 12ths. So then they're the same denominator. It makes it easier to add the numerators. And 12 12ths is still the same as 1 pi. So basically, I'm going to take 5 pi 12ths, and I'm going to add 12 pi 12ths. So that gets me to 17 pi 12ths. 17 pi 12ths is still less than my 24 pi 12ths, so I get to keep going. So now let's take 17 pi twelfths and add 12 more pi twelfths. That gives me 29 pi twelfths. And hey, look at that. 29 pi twelfths is bigger than 24 pi twelfths, so that means that answer is too big. We're done for that line. Now let's go to the next one. 7 pi twelfths plus 12 pi twelfths gives me 19 pi twelfths. 19 is still less than my 24, so I keep going. 19 plus 12 gives me 31 pi twelfths. That one is bigger than my 24 pi twelfths, so that one's too big. We're done. So now that we've reached the point where we're too big on both of these, that means these ones are our answers. So if it said list all answers, we would be right here. That would be our answer. If it said list the answers between 0 and 2 pi, these are all the solutions between 0 and 2 pi. Basically meaning I could plug all 4 of these answers in here for x in your calculator, and they will all give you that answer when you plug it in. So basically, it's kind of the same thing with the plus 2 pi k and all of that. The only difference is because we have this 2x inside, we had to divide everything by 2, which changed our answer slightly. And then we had to list them so we would only get the ones between 0 and 2 pi. So that's our first example of this kind of a problem. Let's try one more together before I have you try some on your own. Let's start with this one. Cotangent of 3x equals 0. Start by getting rid of the cotangent. So I get 3x equals arc cotangent of 0. Let's find this on the unit circle. So we want what angles give us a cotangent value of 0. If it's a cotangent value of 0, remember cotangent is x over y. So we want to be able to do x divided by y and get 0 as our answer. So that's going to happen up here at pi halves and down here at 3 pi halves. Those are the two places that will give you a cotangent value of 0. So same thing we did last time. We're going to start by listing the all answers and set these equal to 3x because that's what I've got. Now if I listed these answers as all, I could do pi halves plus 2 pi k and 3 pi halves plus 2 pi k, or because they are exactly pi apart, I could just say pi halves plus pi k. And that's going to give me all my answers. Now let's solve for x. Divide by 3, or times by 1/3. Same thing. So x equals pi 6 plus pi thirds k. So once again, if the question said find all answers, this would be my answer. That's all. However, if you read the instructions, once again, it says between 0 and 2 pi. So let's list them. My first answer is pi 6. Now I'm going to change everything to be 6 in the denominators. It'll help me with adding these fractions. So if I change the 2 pi, that would be 12 pi 6. Has a 6 in the denominator, and 12/6 is the same as 2. And if I change the pi thirds, that would be 2 pi 6. Ooh, let's do it this way. Because 2/6 is still 1/3, except now we have the 6 denominator. So I have my first answer, pi 6. I'm going to keep adding 2 to the numerator until I get bigger than 12. That's the idea. So 1 pi 6 plus 2 gives me 3 pi 6, or pi halves if you wanted to simplify it. I'm going to add 2 to the numerator again, gives me 5 pi 6. I'm still not bigger than 12, so I keep going. Add 2 again, give me 7 pi 6. Still not bigger than 12, keep going, add 2 again to get 9 pi 6, which also simplifies to 3 pi halves. Keep going to get 11 pi 6. Still not bigger than 12, so now keep going to get 13 pi 6. That one is finally bigger than my 12 pi 6, so that means these are my answers. So hopefully you're starting to kind of get the hang of this. Let's look at example 5. I'll get you started, then I want you to pause the video and try to finish this on your own. So first things first, this is a cosecant problem. So I'm going to flip my answer to make it a sine problem because it's easier to find those on the unit circle. Then I need to do arcsine. So I get 1/3 x minus pi equals arcsine of 1/√2. So you need to go to your unit circle, find the two triangles that have that sine value or that y value, list all your answers that are set equal to this, then finish solving this for x to change your all answers, and then finally list your all answers so you only get the ones between 0 and 2 pi. Try this one out on your own and then come back to check your work. Let's see how you did. So I have two triangles that have the same y value. I'm at pi fourths and 3 pi fourths. So I come over here to my all answers, set it equal to pi fourths plus 2 pi k, my first answer. Set it equal to 3 pi fourths plus 2 pi k, my second answer. Now I am solving for x, so I add pi to both sides. When you're adding, you only need to do it to the angle. You don't have to add it to the 2 pi k. But when you're multiplying, because we're multiplying by 3 here, that's when you have to distribute that 3 and multiply it to everything. So when I did that on both sides, I got 15 pi fourths plus 6 pi k and 21 pi fourths plus 6 pi k. Looks like I'm in fourths this time, so I changed my 2 pi to 8 pi fourths. And I noticed right away that my first answer, 15 pi fourths, is too big. It's bigger than 8 pi fourths, so that one doesn't work. And my first answer for the other one, 21 pi fourths, is also bigger than 8 pi fourths. That one's too big, which means neither of these work. So my final answer is D and E, one of our favorite answers. Let's do one more for this video and then we're done. Let's solve this one, example 6. We have secant squared, which means the first thing we got to do is square root, so we can get rid of that squared. I have secant of x equals square root of 4, which is plus or minus 2. Remember, we don't like secant, so I'm going to change this to cosine by flipping, and then do my arc cosine to solve for x. So I get x equals arc cosine of plus or minus 1/2. And once again, I want my answers between 0 and 2 pi. So I want you to pause the video, find the triangles that have an x value of plus or minus 1/2. Hint, there's actually 4 triangles this time. Then you're going to list all the solutions that lie between 0 and 2 pi. So try that on your own and then come back to check your work. Let's check your work. Like I said, there are 4 triangles this time. These two have an x value of positive 1/2. These two have an x value of negative 1/2. So I have pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. So if I want to list all, notice this time I just have x, so I don't need to do anything extra here. I just have x equals. I have pi thirds plus pi k, because I noticed those are symmetric. And I had 2 pi thirds plus pi k, because I noticed those are symmetric. So if my question said list all my answers, this would be my final answer. I'm good to go. Pi thirds plus pi k and 2 pi thirds plus pi k. However, I want between 0 and 2 pi, so I changed everything to thirds. So 2 pi becomes 6 pi thirds, and pi becomes 3 pi thirds. And then I started listing them. So pi thirds is my first one, and then I added 3 to the numerator to get 4. 4 is still less than 6, so I keep going. Add another 3 to the numerator to get 7. 7 is bigger than 6, so I'm done. Then I listed 2 pi thirds as my first answer, added 3 to the numerator to get 5. 5 is less than 6, so keep going. Added 3 to the numerator and got 8. 8 is more than 6, so I'm done. And those are my answers. So that is some examples of a little bit more complicated trig equations that are on the unit circle. For the last video for this lesson, we have 2 more complicated trig equations that are not on the unit circle. So get your calculator back out. We're going to go back to some calculator problems.